Excellent. Welcome, welcome. Not sure why my webcam is not integrating properly, but we will do our best here. So let's check out our third lesson on acids and bases. We're going to talk about the acid-base theories. So two theories explain the acids and bases behavior. So what exactly are acids and bases? Okay, I've mentioned this in the previous videos, but now we're going to go into detail. Acids are compounds that react with water to make an acidic solution. Okay, any compound that reacts with water and makes it acidic is considered an acid. Well, bases are the opposite. They're compounds that react with water to produce a basic solution. Okay, so anything that makes the solution basic is considered a base. Okay, it's simple, basic, overarching theme. Now the details of the theory. Svante Arrhenius, Swedish chemist, devised this theory way back when because he wanted to describe why some things make water acidic and other things make water basic. And he discovered that acidic compounds have something in common. They all release this hydrogen or hydronium ion as the only positive ion in solution. And he also discovered that bases are compounds that releases hydroxide ions as the only negative ion in solution. So Arrhenius' theory was before its time, but for the time, very useful. Okay. Here's a quick demonstration. When you take an H plus ion and it bumps into a water molecule, it makes an H3O ion, H3O plus ion. So that's why every time you see me mention acids, I mention H plus slash H3O plus because they're synonymous. They're the same thing. Because solutions require water. So an acid producing H plus means the H plus is going to bump into a water molecule and make the H3O plus. That's kind of the point here for acids and bases under Arrhenius theory. The formation of the H plus and H3O plus. So if you have an acid compound like HCl and you add water, it's going to make hydronium ions and chloride ions in solution. These are ions in solution, so the solution is an electrolyte and it will conduct electricity. Kind of cool stuff. Let's see what else we got here. Base formation. Base formation is when sodium hydroxide or some other compound containing the hydroxide ion gets put into water and produces a sodium ion and a hydroxide ion in solution. Again, positive and negatively charged ions dissociate in solution, allowing the water to conduct electricity, which means that the base, sodium hydroxide, is an electrolyte. Cool. Problems with Arrhenius theory. Problem is that not everything has the ability to produce OH negative, but many things test as bases even though they don't have the OH negative hydroxide in it. So we needed another theory to explain why those other compounds aren't behaving by these rules. The theory will need the modification, but first, the general rules of Arrhenius acid and bases. Acids produce H plus ions. H is usually the first element in chemical formulas according to reference table K, L, and M. Those are our acids and bases. K is common acids. You'll see at the formula's beginning, there's usually always an H at the beginning of the formula. Bases produce hydroxide, and the OH hydroxide usually ends the chemical formula. So the common base table has 3 formulas that have OH in them and one that does not. That one that does not is why there's a problem with Arrhenius theory. The alternate acid-base theory is Bronsted-Lowry's theory, and that's why this theory was created, because ammonia, aqueous ammonia, was known to be basic, but they couldn't explain why. Some compounds do not obviously contain H plus or OH negative. So this explanation was created. Bronsted-Lowry, aka alternate acid-base theory acids, donate H plus to a water molecule, making them into the H3O plus. So some compounds actually react with water to make them acids, and some compounds actually react with water to make them bases. So the compound itself doesn't have the acid or the base part in it, but the reaction of the compound with water creates the acid or the bases part in it, which is why this theory really does work. Okay. Here is what happens with ammonia, a base, and water. The water molecule bumps into an ammonia molecule. The ammonia steals a hydrogen atom, aka a hydrogen ion, from the water molecule, creating the OH negative in the process. So NH4 plus is acting as is now the acid, and the OH negative is now the base. So ammonia accepts the H plus ion, creating a leftover hydroxide ion from the water molecule in the process. The OH negative ion hydroxide is therefore created indirectly. So that's why the alternate theory works. Examples: common acids, check them out. These all react with water to produce hydronium ions in solution. And these all react with water to produce hydroxide ions in solution. We don't hit up any other acids aside from the ones that are in the reference table. So pay attention to your common acids and common bases. And that brings us to the end of lecture 3 on acid-base theory. Remember, acids produce hydronium, bases produce hydroxide. Water's always in the picture. Acids and bases are electrolytes. The alternate theory said that an acid is anything that gives up an H plus in solution, and a base is anything that takes the H plus in solution. So I'll see you next video for number 4. See you later, kids. Click the video.